So Bones was asking a little bit more about our solar system, about what exactly makes up our solar system and how does it work and how does it move. So that's what we're going to talk about today, Bones. Sound good? All right, let's do it. The solar system. The center part of our solar system is the sun. We talked about that in the last video. Okay. Now the sun is ginormous. It's huge. It's more than 1,000,000 times as big as the Earth. All right. And with something being that large, it produces a large amount of gravity. And this gravity is going to be the key to holding our solar system in place. All right. Now, we believe our solar system is heliocentric. We're somewhere near the center of the universe, from our perspective anyway. And that's the common theory that the scientists are going with. Okay. So important to remember that the sun is the center of our solar system. All right. Now let's take a look about what goes on outside of our sun. Okay. We have planets. All right. Now, the reason our planets don't just go flying away, okay, is because of gravity. Remember, gravity is that invisible force that keeps us here on Earth, so we don't go floating away. Well, gravity between the sun and all of its planets help the planets stay in something that we call an orbit, okay? That's the path, that's the track that the planets go around the sun on, okay? Now, each path is a curved path. Okay, it's closed. It's like going to the track and running the mile in phys ed class. Okay, if you stay in your lane, that is your orbit. All right, and the center of the field would be where the sun would be located. Now, these paths are elliptical. They're not quite circular. Okay, so they're more of like an oval shape than they are an actual circle. A lot of diagrams you'll see, they'll just draw the solar system. It looks like the planets are going around in circles when they're actually not. Okay, it's a little bit more of a spherical path. Now, we break up our planets into two different types of planets. We call them terrestrial planets and Jovian planets. But again, remember, these planets are held in their orbits, okay, as they revolve around the sun by gravity. Now, the four inner planets are called terrestrial planets. Here they are: Mercury, Venus, Earth, and Mars. These are your four inner planets. They are small, they are very dense, and they are said to be rocky. Okay? Small, dense, and rocky. These are your terrestrial planets. Then we're separated, okay, they are separated from the outer planets by an asteroid belt. Here's an asteroid belt. Asteroids we're going to talk about in another video later on. Asteroids are these big chunks of rock that are stuck in the asteroid belt, which is what their orbit is. Okay? Outside of the asteroid belt, these big chunks of rocks going around, we find the Jovian planets. These are the Jovian planets. We've got Jupiter, Saturn, Uranus, and Neptune. Okay? Pluto is no longer considered a planet. Okay? Pluto was a rebel. He didn't want to, stay in his curved orbital path. He wanted to cross over other orbital paths. He didn't want to spin the right way. Pluto is just a rebel, so he kind of got kicked out of the planet club. But he still is a part of our solar system. We'll talk about him later. So anyway, the outer planets, starting with Jupiter, Saturn, Uranus, and Neptune. These planets are called Jovian planets. They're large, they're gassy, and they have a very low density. Okay. For example, Saturn has such a low density that if we were to throw it in the ocean, it would actually float. Its density is actually less than 1. Okay. So we've got inner planets, we've got outer planets, we've got asteroids that we find in an asteroid belt. We have comets, which we'll talk about later. Comets are a big chunk of icy rock that go around in orbit, go around the sun as well in our solar system. And we also have meteors and meteorites, which can fly throughout the solar system as well. That's our solar system. That's what's made up in our solar system. Now, the reason everything looks so small is because everything is so spread out. There's a lot of space in outer space. That's why we call it space. Okay? And so all these planets have a lot of room to be able to move around in. Now, how big is everything really? Let's take a look. Here's our terrestrial planets. Okay, you can ignore Pluto. Okay, Pluto. See, he's being a rebel again. He joined the picture. He shouldn't be there, but that's okay. You can see how small he is, and since he's so far out, that's one of the rules he broke. He's supposed to be a big gassy planet when in fact he's a little small one. All right, so we've got Mercury, Mars, Venus, and Earth. These are your terrestrial planets. Remember, small, dense, rocky. Those are the three things you have to remember at terrestrial planets. And these are located closest to the sun, inside the asteroid belt. Okay? Now, to remember where the asteroid belt is, just think about where you wear a belt. You wear a belt around your waist, about the middle of your body. Well, the asteroid belt, okay, is located in the middle of our solar system, separating the two halves of planets. So in this picture, the Earth and Venus, they actually look pretty big. But you compare these to the Jovian planets, and they're quite small. Here's the Jovian planets. We've got Jupiter, Saturn, Uranus, and Neptune. Look down here. Okay, look how small these are compared to the other planets. Much, much smaller. All right. Now, since these planets are farther away, okay, it takes them a longer amount of time to go around the sun, to orbit the sun one time in their orbits. Okay. The closer planets are to the sun, the quicker they can go around it. Again, going back to our track analogy. Okay, if you're running a race against someone and you had to choose between the inside lane or the outside lane in order to race them, you'd want to choose the inside lane because it's less distance to go around the track. If you choose the outside lane, you have to travel a longer distance to go around the track, thus taking a longer time. Okay, so here's your Jovian planets. They're very large, they're gassy, okay, and they have a very low density. All right. Everybody always talks about the eye on Jupiter here. All right, that's a big storm that's been going on for millions of years on Jupiter. Pretty wild. Now, we also have moons in our solar system, okay? And every planet has a different amount of moons, all right? And they're still discovering different types of moons on all the different planets. The moon that you're going to have to be aware of and you're going to have to know about is just the Earth's moon. This is the one that you have to know. We have one moon, okay? We see it every night. All right. It looks like it changes shape, but it doesn't. It's just reflecting different amounts of light. And we're going to have a lot of discussions about how the moon affects us here on Earth and what its purpose is and what it does for us. But just understand that within our solar system, the center of our solar system is the sun. It is surrounded by planets that go around orbits. Okay. They're held together in their orbits by gravity. We have inner planets separated from the outer planets by something called an asteroid belt. Okay, there is meteors in our solar system, and there's comets, and finally moons. Okay, so now the planets are the things that are actually going around the sun. Moons are actually going around their individual planets. Okay, we'll talk more about our solar system and everything in it next time. Take it easy.